This lesson is about writing equations of parallel and perpendicular lines. Some tricky stuff, but with practice, not too bad. What did we learn about parallel lines? Well, two things. One, parallel lines have the same slope, which is key. You know they have the same slope, then you just rewrite it into the next equation. And they never intersect, which is actually what it means that they're parallel. I was told the way to remember this is by looking at the word parallel and looking at the two L's, and that's what parallel lines are. These two letters are parallel. However you remember it, might just have to memorize it, doesn't matter. Let's give it a shot. So, equation of a line that passes through the point -3, -5 and is parallel to the line y equals 3x minus 1. So we have the line y equals 3x minus 1. It's in slope-intercept form. The slope is 3. So we grab the point -3, -5, and we label them x1, y1. Let's use point slope to do this. Y minus -5 plus equals 3 times x minus -3 plus. Let's turn it into slope-intercept. Distribute 3x plus 9. Get rid of the 5 so we get y alone. Y equals 3x plus 4. So there's our equation. Should be parallel. Let's graph it, see if it is. So now we need to graph them. Y equals 3x plus 4. That's the one we want to graph. I want to see if it goes through -3, -5. Let's graph it and check. So, up 4, 1, 2, 3, 4. Up 3 over 1. I'm also going to do down 3 over 1. Down 3 over 1. Down 3 over 1. Just in case I'm not drawing my lines properly. And let's take a look. Is that parallel to y equals 3x minus 1? Well, we know it is because it's got the same slope, but it never hurts to make it visual. Draw our line in. Good. And where's the point -3, 5? 1, 2, 3. 1, 2, 3, 4, 5. There's the point -3, -5. Yes, it goes through. Moving right along. Try it again. This time I've made your life miserable. I've given you a line that is not set up in slope-intercept form, so you've got to go mess with it. So 4x minus 2y equals 8. Subtract 4x from both sides. -2y equals -4x plus 8. Divide by -2. Y equals 2x minus 4. M equals 2. So that's our original equation. Let's graph that real quick. We're going to graph a parallel line to it. We'll put that line in green again. That's our original line. 2x minus 4. 1, 2, 3, 4. Up 2 over 1. Up 2 over 1. Up 2 over 1. And now, let's go find our parallel line. M equals 2 and the point is -3, 2. Call that x1, y1. y minus 2 equals slope 2 times x minus negative 3 plus plus y minus 2 equals 2x plus 6. Add 2 to both sides. Y equals 2x plus 8. 1, 2, 3, 4, 5, 6, 7, 8. Since there's nowhere to go up, we'll go down. 2 down, 1 to the left, 2 down, 1 to the left, 2 down, 1 to the left. And the point is negative 3, 2, 1, 2, 3, 2. There it is. Good. Works. Flipping over, do perpendicular lines. Perpendicular lines are at right angles. And the slopes are opposite reciprocals. So for example, if m equals 1/2, m perpendicular would equal negative 2, because you would make it the opposite, which is negative, and reciprocal, which is flipping it upside down. And 1 over 2 becomes 2 over 1. We don't write the 1. So let's give it a shot. An equation of line that's perpendicular. Well, here's our original equation, 3x minus 1. So m equals 3, therefore m perpendicular equals 1/3, negative 1/3. So take that, let's write our negative 3, negative 5, call that x1, call that y1. Let's go point slope. Y minus negative 5 equals negative 1/3 times x minus negative 3, they become plus plus. Y plus 5 equals negative 1/3. X plus 3. Distribute. Why did I do that twice? Let's distribute right away. Negative 1/3 x. Negative 1/3 times 3 is negative 1. Subtract 5 from both sides. Y equals negative 1/3 x minus 6. Let's do a little graph in here. And let's put the new one in blue. Down 6, 1, 2, 3, 4, 5, 6. Down 1 over 3, 1, 2, 3. Down 1 over 3, 1, 2, 3. Up 1 over 3, 1, 2, 3. Up 1 over 3. Okay. Connect the dots. Always a tricky proposition. Put our original in green and see if it actually looks like it's at a right angle. That's 3x minus 1. 2, 3, 1. 1, 2, 3, 1. That should do. And where's our point that we wanted to find? Negative 3, negative 5. 1, 2, 3. 1, 2, 3, 4, 5. There it is. Negative 3, negative 5. So they're perpendicular, right angle, and it passes through negative 3, negative 5. Tricky. Last one. Taking some time here. So we know that 4x minus 2y equals 8. Same equation as before. We'll go through it again. Negative 2y equals negative 4x plus 8. Divide by negative 2. Get y equals 2x minus 4. M equals 2. M perpendicular equals negative 1/2. Flip it and put a negative out front. So the new line, if these are my points, and we'll write this down again. Negative 3, 2, x1, y1. Y minus 2 equals negative 1/2, x minus negative 3. Distribute. Y minus 2 equals negative 1/2, x minus 3/2. Add 2. Add 2. Y equals negative 1/2 x, and negative 3/2 plus 2 is 1/2. Do a little graphing. And let's put our original in red, 2x minus 4. 1, 2, actually I can't do that. Yes I can. 1, 2, 3, 4. Up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. That's off a little bit. And we'll have to do. That's y equals 2x minus 4. Let's put the new one in green. Negative 1/2 x plus 1/2, so that's about there. Down 1 over 2 is here. Down 1 over 2 is here. Looks pretty perpendicular. Y equals negative 1/2 x plus 1/2. And let's go find our point. Call it a day. Negative 3, 2. 1, 2, 3. 1, 2. Right about there. Negative 3, 2. Very complicated stuff. You may have to replay the video several times to get it, but start practicing problems right away. Good luck.